Hi, in today's lesson we're going to be talking about measuring angles. So in order to get started, let's go ahead and define what an angle is. An angle is simply two rays with a common endpoint. Notice the diagram on this page. We have point K. Point K is the endpoint of ray KB and ray KM. So we have two rays that have the same endpoint. These two rays form an angle. When we name an angle, there are three different ways that we can name it. First of all, we can name an angle by its vertex. The angle symbol looks like the less than symbol, except the bottom comes straight across. So this is our angle symbol, and we can name the angle above angle K. A second way to name an angle is with 3 points, but the 3 points must be in a specific order. We can use a point that exists on one side of the angle, the vertex in the middle, and then a point on the other side of the angle. For example, we could name the angle above angle BKM. Notice that the K, which is the vertex, must be the point in the middle. We could also say this backwards and say angle MKB. It does not matter which side of the angle we name first, as long as we put the vertex in the middle. The last way to name an angle is with a number, if there's a number inside the angle. For example, if there had been a number inside this angle, like 3, then you would have been able to name it angle 3. We're going to talk about the 4 types of angles that we'll use in this lesson. You should be familiar with these 4 words. An acute angle is any angle that measures less than 90 degrees. A right angle will be any angle that measures exactly 90 degrees. If something is a right angle, it should have a symbol in the corner that looks like a little square to indicate that it is exactly 90 degrees. An obtuse angle is any angle that measures more than 90 degrees but is less than 180 degrees. And the last kind of angle is called a straight angle. It's an angle that measures exactly 180 degrees. A straight angle will make a straight line. It's two 90-degree angles put together. Postulate 1.7 is called the protractor postulate. This is similar to the ruler postulate that we learned in the last lesson. Consider ray OB and a point A on one side of ray OB. Every ray of the form OA can be paired 1-to-1 with a real number from 0 to 180. In other words, we can take our angle and start with a number like 0, and as we go up to 180, which would be a half circle or a straight line, we come across and we find the other number on the inside of the protractor. Since it's between 120 and 130, we would call this number over here 125. So the measure of this angle is the larger number minus the smaller number, or 125 degrees. Notice if we had really wanted, we also could have used the numbers on the outside of this protractor. We should really use the 0 so that we can do the 125 minus 0, but it is okay if we look at this again. We could call this number right here 55 because it's between 50 and 60. We could call this number 180. Notice this time I read both numbers from the outside of the protractor. If I again take the larger number and subtract the smaller number, I will get 125 degrees. So either way, the measure of this angle is 125 degrees. So let's look at how to measure some angles with a protractor. Our first angle, angle LKN, if we trace it, we can look at this and see that LKN looks like an obtuse angle. To measure this angle, since one ray is on the number 0, let's use the inside of the protractor. So ray KN is at 0, ray KL is between 140 and 150, which is 145 degrees, and so the measure of angle LKN, which we denote with an M and then the angle symbol LKN, is 145 degrees, which would be an obtuse angle. Now let's look at the measure of angle JKL. Angle JKL looks like an acute angle. It is less than 90 degrees. Since neither of the rays line up on 0, it really doesn't matter whether we use the inside of the protractor or the outside of the protractor. So I'm going to start by using the outside of the protractor. I notice that ray KJ is at 90 and ray KL is between 30 and 40. We're at about 35 degrees. So again, if I take 90 and subtract 35, I get 55 degrees. So the measure of angle JKL is 55 degrees, which is an acute angle. If I had wanted, I could have used the two numbers from the inside of the protractor, which would have been 145 and 90. And 145 take away 90 is still 55. So either way, I would have gotten the same answer. Okay, now let's look at our last angle together. Our last angle says we're looking at angle JKN. So JKN, we can tell by drawing this that that is a right angle. So angle JKN is a right angle. Which means we know that the measure of angle JKN should be 90 degrees. We can confirm this on the protractor. If we use the two numbers on the inside, we go from 0 to 90, and 90 minus 0 is 90. If we wish to use the numbers on the outside, we would have 180 and 90, and 180 minus 90 is still 90. So either way, we get the exact same answer. We talked about the word congruent in our last lesson. So congruent angles are simply two angles that have the same measure. Now we're going to look at another postulate called the angle addition postulate. The angle addition postulate is very similar to the segment addition postulate, which we learned in the last lesson. It says if point B is in the interior of angle AOC, in other words, if point B is somewhere inside angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. In other words, the two smaller angles can be combined or added together to equal the measure of the entire angle AOC. Let's look at how to use the angle addition postulate to solve some problems. In this example, we notice that the measure of angle RQT is 155 degrees. Angle RQT is the larger angle, and it is made up of the combination of RQS and SQT added together. So we can write an equation that says that 4x minus 20, one of the smaller angles, plus 3x plus 14, which is the other small angle, will equal the measure of angle RQT, which is 155. We start by combining like terms, and 4x plus 3x is 7x, and negative 20 plus 14 is negative 6. So 7x minus 6 equals 155. We now add 6 to bring that to the other side. So 7x is equal to 161. If we divide both sides by 7, we find that x is 23. Now, it did not ask us just to find x. We need to find the measure of each of those smaller angles. So we know that the measure of angle RQS was 4x minus 20. So I'm going to take 4 times my x value and subtract 20. 4 times 23 would be 92 minus 20. So the measure of angle RQS is 72 degrees. The measure of angle SQT, or TQS as it's stated in the problem, is 3 times x plus 14. 3 times 23 is 69 plus 14, which is 83 degrees. So the measure of angle TQS is 83 degrees. We know that this answer is reasonable because if I add 72 and 83 together, I get a total of 155 degrees, which is what these two angles are supposed to add up to according to my problem. Notice in our next example, it says that angle DEF is a straight angle. If we remember what a straight angle is, we know that that means that the entire angle DEF adds to equal 180 degrees. So the two smaller angles, DEC, which is 11x minus 12, and CEF, which is 2x plus 10, can be added together to equal a total of 180. Now we solve like we did in the last problem. We'll combine our like terms to get 13x minus 2 equals 180. We continue solving by adding 2 to each side, giving us 13x equals 182. We divide both sides by 13, and x is now 14. In order to find the measure of each of the angles, we now substitute that number back in. So the measure of angle DEC is 11 times the x value of 14 minus 12. We have 154 minus 12, which is 142 degrees. So the measure of angle DEC is 142 degrees. The measure of angle CEF is 2 times the x value of 14 plus 10, or 28 plus 10, which is 38. So the measure of angle CEF is 38 degrees. I can check my answer by adding 142 and 38 together, and I find that the total is 180 degrees, which is exactly what I want to make a straight angle. Our last example says ray DB bisects angle ADC, so that the measure of angle ADB is x minus 3 degrees, and the measure of angle BDC is 2x minus 13 degrees. I'm asked to find x, then I'm asked to find the measure of angle ADB and the measure of angle BDC. Now, in this problem, it might help us to start by drawing a picture. In geometry especially, a lot of times, it's easier if I can see what's happening. So, as I read this problem, I see that ray DB bisects angle ADC. In other words, I have an angle, and D is the vertex. I'm not sure exactly what the measure of this angle is, so I just draw a picture. It doesn't really matter at this point. What does matter is that DB should bisect that angle. In other words, I can draw a ray going through the center of this angle, which cuts the angle into two equal parts. And this is ray DB. I'm told that the measure of angle ADB, which is this smaller angle on the left, is a total of x minus 3 degrees. And the measure of angle BDC, which is the angle to the right, is 2x minus 13 degrees. Since I know that these two angles are supposed to be congruent, an appropriate equation would be x minus 3 equals 2x minus 13. And now I solve this equation for x. First, I'm going to subtract x from each side, giving me negative 3 equals x minus 13. I now need to bring the number to the left, so I add 13 to both sides, giving me 10 equals x. Now I'm asked to find the measure of each of the smaller angles. So to find the measure of angle ADB, I substitute x to be 10. So x minus 3, or 10 minus 3, is 7 degrees. So the measure of angle ADB is 7 degrees. I know that the two smaller angles are supposed to be congruent, so the measure of angle BDC must also be 7 degrees. I can show that my work is correct by checking the measure of angle BDC and seeing if I indeed get 7 degrees. So the measure of angle BDC is 2 times the x value minus 13, or 2 times 10 minus 13. That's 20 minus 13, which is 7 degrees. So the measure of angle BDC is indeed 7 degrees. This means that my answer is reasonable, since the measures of angle ADB and BDC are the same. That's all for today's lesson, and I'll see you in class.